Okay, so the first example that we have is 2x minus 8 equals 2x minus 16. Okay, so it's a linear equation. Once again, equation means you have two expressions that are equal. So there are definitely multiple different ways for you to solve this problem. So just because I'm doing it one way does not imply that you're doing it incorrectly. So as long as you're staying within the rules of mathematics, don't worry about following each individual step as I do, okay? So one way to solve this is to distribute the 2. So I get 2x minus 16 equals 2x minus 16. Okay, and then I want to solve for x. So I'm going to shift this so that I have all the x's on one side. And in order to do so, since this entire thing is positive, right, to undo it, you have to do the inverse operation, so you have to subtract out 2x from both sides. And in the process, positive 2x minus 2x, positive 2x minus 2x, so I'm left with negative 16 equals negative 16. So that means this is an identity, right? Meaning the solution set looks like x, such that x is all real numbers. Or for that matter, it might be any real numbers, right? So the solution set for this one is all real numbers. So let's look at the next one. The next one says 3x plus 2 times x plus 2 is equal to 5x plus 2. So here, the first thing that I would do is to distribute the 2. So I would have 3x plus 2x plus 4 is equal to 5x plus 2. So combine the like terms. These two terms are like. So if I add 3x plus 2x, I get 5x plus 4 is equal to 5x plus 2. So once I get to here, I want to isolate the x so that I can solve for it. So subtract out 5x from both sides. Once again, from doing so, I cancel out the x's, so I'm left with 4 equals 2, which is not true. So this is a false statement, hence this entire equation is a contradiction, meaning that there is no solution. So this one, it's saying that there's no values of x that you can plug in to make this equation true. So these are kind of opposite ends of the spectrum. For the first equation that we solved, you can plug in any x value and it'll make this entire statement true because it's an identity. For the second one, it's a contradiction, meaning there's nothing that you can plug in for x to make this statement true. Last example that we have is 4x plus 1 equals 11. For this one, 1 is added, so the inverse operation would be subtraction. And now what we have left is 4x equals 10. 4 and x are multiplied, so we need to divide through by 4. So that 4 divided by 4 is 1, so we get x is equal to 10 over 4. So if we were to write the solution set in terms of sets, it would just be 10 over 4. Keep in mind that you could reduce this. So an equivalent fraction would be 5 halves, or you could have written as 2.5. So these are all equivalent to each other, so you could write either one of these. I think for my math lab, it'll tell you specifically to either simplify it or write it as a decimal. So keep an eye out for that. It'll say within my math lab, within the problem, it'll say leave your answer in a certain form. So this one is a conditional. And once again, conditional equation means that there are some values of x that will work, but other values it won't work. So that means that you can plug in 10 over 4 and it'll be equal to 11 once you work through, because it'll be 4 times 10 over 4, which is 10 plus 1, which is 11. But if you plug in any other values, this equation won't hold because the solution set only consists of 10 over 4. Okay, so the next video will have some more terminology before we move on to the other practice problems.